Hello. Hello, Facebook. Welcome to Creators Night for November. My name's Angie Rary, and I am the Customer Service Manager for YoraHome. And tonight we are doing 3D carving with the 6060. We're going to do things a little bit differently tonight. We're not actually next to the machine, but we're going to walk you through the process and show you videos of the machine carving, since if we were actually doing this next to the machine, you would never be able to hear us. So we have video clips of each step of the process and pictures of what everything looks like so that you can actually see what's going on. I will be monitoring this feed, so if you have any questions at all, just go ahead and ask, and I will be responding while Jim is doing the lessons. So I'm going to hand over the microphone to Jim, and hopefully you enjoy our presentation. Have a great evening.
All right, good evening, everyone. As Angie mentioned, we're doing things a little bit differently. We got to looking, and realistically, the noise level from the machine and everything was going to be making it way too hard for people to hear what we were doing. So we don't want to keep playing that game and trying to scream over it or anything else like that. Made it harder for everyone to understand what was going on. So what we're going to be looking at today, as Angie mentioned, is bringing a 3D carving capability in with the SilverBack. Now, this is something that is not necessarily a direct input into easel, which is, our most common software that we use with the machines. What I'm going to be using is Vectrix Vcarve Desktop, which is a separate program. This particular program does require licensing. There are different levels of Vectrix software, so it's entirely up to the user to determine which version they want. It ranges in price from around $200 up to $2,000. So you really want to look at what features you want, what capabilities you want on their website. This sort of thing is also available via Carveco. We are a Carveco partner. For anyone that has purchased a 3018 or a 6060 from us, we do have a link on our website that will allow you to sign up for a free 90-day trial of Carveco. And that would give you a chance to check out the Carveco Maker software and do these sorts of feeds on your own. Or projects, I should say. Carveco is subscription-based, very similar to Easel. We do offer a 12-month subscription as well. We can get that for you. Both of those programs, either Carveco or the Vectrix series of programs, do not directly control the machine. So what they do is they will generate the G code that we can then import into Easel and use Easel as just the means of controlling the machine. So what I'm going to do is go through the steps of bringing a file into the software, getting the tool paths for each bit selection that we want to do, and then showing you how that actually processes and generates the G code. And then I'll show, as she mentioned, the steps as they go through. We've got some video that shows how it proceeds through, and I'll run those real quick as well. And that way we can see what it's going to look like at each step of the process. So the first thing I'm going to bring up is the file that we started with. What we're using is what's called an STL file. So that is a file type. You commonly would see these referred to as 3D printer files, but they can also be used for any 3D elements such as a carving. So in this case, Angie found a nice Thanksgiving related one. So it's just a basic sign or plaque. It says be thankful, happy Thanksgiving. We've got some leaf and banner elements in there. And we can see that it's about a 9 by 8 plaque size. So if you open up an STL file on a Windows computer, by default it opens up in the Paint 3D program, so you can kind of see what it's going to look like. So what we want to do now is take that STL file and bring that into Vcarve. So what we're going to do there, let me switch to Windows real quick. This is the Vcarve desktop program. When you open it up, you have this workspace, and we want to create a new file. So I'm simply going to come up here, up in the upper left, and I'm going to create a new file. What it wants to know first is, are we doing something on a single-sided, a double-sided, or a rotary? Obviously, our machine does not have a rotary, so we can't be doing that. And we haven't quite gotten to that fanciness of a double-sided carve. Can be done by flipping it over, but not something we necessarily want to jump into. I want to make this a little bit easier, so what I'm going to do is, for my job size, I'm going to tell it that I have a 12 by 12 inch piece of wood that is 3/4 of an inch thick. The 0 position for the Z-axis is going to be my material surface. That's coinciding with the way we normally operate in easel by finding the top of the wood. That's where we set our bit to for our 0 point if we're using a 3018, or if you're doing manual on the 6060, or you reference off of the material surface with your Z probe for the 6060 as well. The XY datum position, that simply starts it in our lower left position. That's typically where we want to put things. So when I click OK, we now have our workspace that coincides with the size that we just developed. At the top of the screen here, we've got two tabs, a 2D view and a 3D view. If we click on the 3D view, it shows us a pretend piece of wood. In this case, I selected pine because that's what I was working with. But you can change it to something different if you like. The 2D view basically just gives you the layout of the workspace. So in order to get our STL file in here to work with something a little more advanced than just the 2D that easel is used to, we come up here to the model menu and we select the import component or 3D model. Now that may not be showing up on the screen properly from the looks of it. So it would be the third menu option, and import component 3D model. And what it is asking for is for me to select the file that we want to work with. So I go to my file navigation. Let me see if I can get this to show up properly for you. I'm going to make a little quick change here. Bear with me just a moment while I change up something. And let's get it to show you my entire monitor. So, are you able to see my screen now? Let's see here. I'm waiting to see. Yep, it's updating. There is a little bit of lag time, so I want to make sure that it shows up. So, on the model menu, we go to our import component or 3D model. That brings up a typical Windows file open dialog. So we go to the file folder that we have our Happy Thanksgiving STL file, and we tell it to import that. And what it did is it brought us in to the transform menu. So what we're going to do here is we see that if we zoom in on this, we have our layout. We can see the thickness of it. In this case, it's approximately 3/8 of an inch thick. We can see where it's located on the screen. Over here on the left-hand side of the screen, we have our model size. It's telling us that the x-axis is approximately 9.9 inches, the y-axis is approximately 7.3 inches. I'm going to click on the center model to get it into the center of my workpiece, because that makes things a lot easier for positioning on the screen. You can click and drag to rotate this view around. You can see how things are laid out. You can make sure that there's nothing on the underside of it, that sort of thing. And you can kind of get an idea now of how it's going to lay out the carve. So I'm going to click on the position and import screen or button. Right here we want to know, are we going to discard data below the 0 plane? What that is this imaginary line here that is at the bottom of the design, and we can actually set that a little bit lower. We know that we're at 0.375 inches. So what that just did is it moved that imaginary line right down to the bottom of my design, that gray square that you can see. So we want to have that matching the depth of our design so that we carve the entire thing. By discarding any data below that 0 plane, what that does is anything that would be accidentally sticking down below that level on the design would be eliminated or not carved. Since it was currently set to carve at half of that, we probably would have lost some elements in this, and we don't want that, certainly. So now I can import my model. And that brings us back to our 3D view on our pine board, and this is what we should end up with. But first, we've got to tell it how to carve. We've got to tell it what tools we want to use and how we want them to run. So one other thing that we want to do first is, do I want to be able to cut this out of the board? Because if I just carve this on the board, I'm going to have this big design right in the middle of the board, and I would then have to cut around it. That's not a fun thing to have to do. So what I'm going to do is switch to my 2D view. That gives me this nice, just grayscale look, but it allows me to position things on the screen. And what I'm going to do, some STL files have a vector around the outside of them that would make this step a little bit easier. This particular one does not, unfortunately. So what I'm going to do is I'm going to go to my drawing tab here on the left. I'm going to click on the draw ellipse. And it's going to ask me, how big do I want my ellipse to be? Well, I know that my x-axis was about 9.9 inches and my y-axis was about 7.5. So, and it would help if I actually clicked on the right one. So x-axis of 10 inches and a height or y-axis of 7.5 inches. Create that, and it wants to put it right there. So I close. Now if I want to move this, I can bring it up here. We can see that its size is a little bit off. So I can click and drag to modify this a little bit, change the size of it. See if I can get to just the right icon. Oh, looks like I inadvertently got two of them on there. So let's check that again. Create and close. There we go. So you can see that pink dotted line around the outside edge. That's where I would be cutting out. So I want to make sure that I get that as close as possible. That's a situation with this particular STL file that required me to do so. So what I want to do now is create my toolpaths. So I'm going to click this little icon right up here that switches me to the toolpath commands. It's right up at the top bar of the screen, right above the drawing window. That closes your view on the left hand side and opens a view on the right hand side now. Apparently we were having some mic issues, so I'll try this, see if that helps a little bit. So when we get to our tool paths, we want to set up our material first. So we click on the set button up here in the top right. And basically this is similar to the settings we see in easel confirming our material size and thickness. We're just reaffirming that our material thickness is 0.75 inches. We're confirming that we want to operate from the lower left corner. We're confirming that we want a 0 on the material surface. The rest of these we should not need to set, so we can simply say OK. The defaults should be acceptable. First one I'm going to set up is the profile toolpath. That's the one that we will use to cut things out. So I'm going to select that vector that we put around the outside edge of everything. You can see it's highlighted in that pink dashed line there. And I'm going to create a profile toolpath. So the profile toolpath is set by default to cut all the way through the board. You'll notice the cut depth is set to 0.78 inches. So that's going to go just a few thousandths of an inch below the surface of the wood so that we cut all the way through our wood, because we want to be able to cut it out. I have selected a ball nose 3mm bit. That is the same bits that are available within the Essential Bit Kit. If you have a different bit, you can simply click on the Select menu. These are the pre-installed bit sizes that are in Vcarve. If you have a totally different bit, you can add your own bit to this software as well. You can select what type of wood you're working with. I'm in a soft wood, so I'm going to go ahead and change that. What that's going to do is alter our feed and speed settings here. For our ball nose bits, 2 flutes, 3mm diameter. We know that we're going to cut totally down to all the way through, so we want to make sure that we have our bit installed properly, obviously. This is set that each pass is going to go 0.75 millimeters. This is a case where you may want to adjust your depth per pass a little bit depending on what type of wood you're in. I'm in a soft wood, so going 0.75 is not really a problem. The spindle speed is not really going to be impacted. On the 3018, if you were trying to do this, it's basically an on-off control for our spindle speed. If you're on the 6060, you have variable speed using the control on the front of the control module. Your feed rate and plunge rate, I'll be honest, sometimes I set these a little aggressively. When you import them into easel with these toolpaths, you can then go ahead and adjust accordingly, just like you could with any other easel project. So if I start this with a feed rate of 1100 millimeters per minute for the SilverBack, which is just fine and dandy, if it's running and I determine that it's a little too fast, a little too aggressive, I can always use these feed rate controls in easel to slow it down. So I'm simply going to select that. That gives us our tool. For the vector, it's going to go on the outside edge of that and move to the right. One big thing you want to do whenever you are cutting something out of another piece of wood is you want to add tabs. What those tabs are going to do is leave just a little bit of material so that when that thing pops loose or cuts all the way through, it doesn't move the cutout piece. It will leave it in place. You will then have to trim or maybe do a little bit of sanding to get rid of those tabs, but that's far more preferential than having to deal with a chunk of wood that jogs about 1/8 of an inch off to one side and gouges it up and ruins your whole project. So we'll click on the Add Tabs, and it's going to tell us it's going to make a tab by default 0.3 inches and 1/8 of an inch thick. If we edit our tabs, it'll ask us how many we want. I'm going to bump it up to about 8 tabs. And I'm going to put the first tab at the machining start point. I don't necessarily want to click on the avoid corners and curved regions because, well, my entire toolpath is a curved region. So when I click on add tabs, you can see over here it added a little yellow T in various spots around the perimeter of our carve. That's where it's going to leave those tabs that we'll have to cut off. So I'm going to close that. For this particular toolpath, I'm not honestly too concerned about ramping. This is going to be a pretty conservative cut. If we were going into some more advanced features, harder materials, then we might want to do that. So now I'm going to calculate down here in the bottom right. Okay, I'm trying without the microphone. Let's see if this is any better, and I'll hold up a second. The mic gain's turned all the way up.
Try and talk.
Anything now? Because I tried removing the microphone, and I'm using just the laptop's microphone instead of our other one. So with that, we should be able to add our tabs. We've now calculated our toolpath, and what we're wanting to do is continue on, and it's giving us a warning that the tool is going to cut through the material because we've told it that our material thickness is 3/4 of an inch, but that we want to cut 0.78 inches. So we want to make sure that we have a sacrificial piece underneath our workpiece before we get started, or we will damage the spoil board or the aluminum bed and the bits to go with it. Okay. So we are okay with that. I'm going to tell it okay. So that shows us our first toolpath. So if we wanted to preview that toolpath, we can click on the preview selected toolpath, and it will show us where it will carve. And you can see that it has carved all the way through the wood except for the sections where those little tabs are. So that tells us that we got everything in the right position. But so far all we've done is tell it, let's go ahead and cut out that outline. We still have to do the rest of the interior of the design. So I'm going to close that toolpath. And now I'm going to set up my 3D roughing toolpath. That's this icon over here on the right hand side. So I click on my 3D roughing tool. Now for this project I've selected a 6mm end mill, and it is set to run at 1350 millimeters a minute. When I did this project earlier, I actually set this at 2000, so I'm going to set that to the same value now. My limit boundary is the model boundary. What that's telling it to do is to look at the aspects of that STL file that we imported. I left this particular project at the default values on everything here. So I'm going to go ahead and calculate this toolpath as well. Now keep in mind, this 6mm bit obviously can't get into that fine detail around the lettering. So what it's going to do is calculate a toolpath that removes the bulk of the material in the larger open areas, but anywhere that it can't fit into, it will leave alone. So I'm going to go ahead and calculate that, and this is what it comes up with for a toolpath. If we preview this toolpath, we can see that it's going to carve out and leave our image looking kind of blotchy. That's expected. It can't get into that fine detail at this point. To get into that finer detail, we close this toolpath. Notice it's now added them here on the list of toolpaths. And now I want to enter a finishing toolpath. Now, for this project, I actually did 2 finishing paths. And the reason I did that was because I knew there was a fair amount of material still to be removed. So I'm going to remove that 3mm bit that is selected, and instead I used a 6mm ball nose. I'm still going to be at my 2000mm a minute. I can leave the rest of my options all the same because all it's doing is telling it what bit to use and then calculate it based on that bit size and what it thinks it can get cut out. So I'm going to calculate it. It comes up with a totally different toolpath. If we preview this one, we now see that we're starting to get more detail. Still a little rough around the lettering. So you may want to either change to a different bit and redo that toolpath, or what I chose to do was simply switch bits and add another toolpath. So I added a third path, another finishing pass, but now I got just my 3mm ball nose. For this one, I wanted to go a little slower. That bit is a little more fragile. We don't want to go too fast and end up snapping a bit. So I left it at 1100 millimeters per minute. Again, leave all my default values, calculate my toolpath. Now we see that it's going to carve pretty much over the entire surface. If we preview this, you can see it gave us more detail in the lettering, it gave us more detail on the leaves, and that pretty well took care of our blotchiness that we had previously. If I wanted to get even finer detail, I could have done that final finishing pass with a V-groove bit. However, in the interest of time, I left it at just this phase as well. This will get us the level of detail that we are happy with for this particular project. It's obviously going to be up to you, the user, to determine how you want it to look. So I'm going to go ahead and close that toolpath. So we have now created all 4 of our toolpaths. So the next thing we have to do is save them. So we have the Save Toolpath button right here. One caveat to this: Easel will only accept being loaded with a single toolpath at a time. So what we need to do is make sure that we select visible toolpaths to multiple files. And we select all toolpaths, and we can see here that we're going to have 4 different toolpaths saved. We have a roughing, a finish, another finish, and then the profile, which was the cutout of it. I've got the SilverBack entered as a machine profile, and I'm using the easel post processor, so that tells me it will automatically generate G-code that is compatible with easel. So I can tell it to save a toolpath. It wants to know where I'm going to save it to. I'm just going to save it to my desktop and tell it I want a new folder. You may want to save it to a USB drive if you're going to work on a different computer to operate easel or that sort of thing. So that has completed everything that we need to do in Vcarve to get us up and running. So now we'd want to get this into easel once my browser opens up. Come on, Mr. Browser. I'm going to go ahead and close Vcarve here real quick. Give me just 1 second. So we're going to close Vcarve. My browser to open up for me. And we'll go back to our screen now. Alright, so we go into our easel screen at our typical easel.inventables.com. Of course, we have to sign in. not going to worry about any of the previous projects. I'm just going to tell it I've got a brand new project. But we can honestly skip over all the design aspects that we're used to dealing with in easel. We don't have to build the elements on the screen. We don't have to import an image, that sort of thing. So what we're going to do is we're going to go to the project menu, and we're going to actually import the G code, because what Vcarve did for us was actually generate the G code. So we generate or import G code, and we have to choose a file. So we choose a file, we go to that folder we just saved it in. The first one I want to run is that roughing pass. I want to do them in the order to remove the most material first and then get our finer detail. So I'm going to open my roughing file, and this is what it's going to drop onto the screen for me. Notice it looks a lot different. This looks like just the simulation side of easel, which is essentially all we are seeing. It's still going to give us a time estimate. You can run this simulation if you like to see, does it make sense? One of the big things I always look at is these red lines going into and out of the design. Is it going to clear any clamps? That's the most important thing you want to look at. We would then go through our normal carve routine. Obviously, I don't have a machine connected right now, so I can't walk through those exact same steps, but it's typical for any carve within easel. It'll have you confirm that the material size is correct. It'll have you confirm that the material is clamped down properly so it doesn't launch across the workshop at you. You're going to set your zero position, whether you're doing that manually or with the Z probe. We talked about the Z probe in the last video. You're going to confirm that the spindle is on, and then you're going to tell it to carve. Once it's carving, you can go ahead and adjust your speed just like you could with a easel generated project. So what I'm going to do real quick here is, while that's sitting there, I actually have a quick video that shows how the program ran. Now keep in mind I'm running this at an exceptionally higher speed than normal, so you can see how it's going. But this is on the easel screen here, showing us what it looks like as far as the simulated toolpath. So I'm just going to run the video here real quick. This should take a few minutes, and we're going to let you see exactly how this looked while it was running. I don't have any sound, that way we aren't deafening people, but this is the roughing pass running at an accelerated rate. If it'll actually run for me. Hold that thought because it's not wanting to run for me. So I'm going to close that program and reopen it and see if we can get it to actually work for us. It worked fine when I tested it, which is why it's not working now, just to spite me. Give me just a second here while I work on getting the speed up so that we aren't watching it forever and ever and ever. This particular pass took about 45 minutes. So let me bring that back over here, and let's see if the play button actually gets us what we want to see. So this is with that 6mm end mill. It still does what most would consider a very convoluted toolpath. Back and forth, move around, go grab a different section. I honestly could not give you a good answer on why it does things in that order. But you can see that it's just removing bulk of material, just in the areas that it thinks that it can get that bit to fit in there. It's leaving those very big splotchy sections and getting just the rough outline. cutting out the bulk of that material in the center where it knows that it doesn't need to have any material left to form the lettering. Again, this video is running at considerably faster than real life speeds because, well, we don't want to sit here for the next hour watching this work. The SilverBack is a lot faster, however, it's not really this fast. You may also notice in this video that I've got that sacrificial board underneath of the material so that I don't damage my spoil board or bit when it cuts through on that final pass. And I've also done a slightly different option. You can see that my actual workpiece, I just drilled some pilot holes in it and screwed it to my spoil board. That way I don't have a clamp in the way. So I've got those screws right there in the four corners holding it down. So let me go ahead and close that one. So that was our first pass. That was our roughing pass, and you can see where it came up. And after that was done, here's what I had. This is what my piece of wood looked like once that was done. We can kind of make out where some of the lettering is going to be. We can see these very, very coarse steps where the contour of the leaves are going to be and the banner is going to be. But obviously, it's not very, very fine detail. So then we want to move on to our second pass. So we would come back into easel. We're going to import G-code again. And we're going to go back and choose that first pass, which in this case was labeled as 3D Finish 3. It's going to validate our code. You don't get to see a lot of the detail in this easel preview, but it's still going to go through the same process. And let me get that video up and running here. Just 1 second. Got to get the speed up where I want it so that it actually goes through fairly quick for us. Alright, so here's the video for that first finishing pass. This is with a 6mm ball nose bit. So it started in the center, it's working its way out and around. Once the dust shoe gets out of the way, you can see that it's starting to knock down some of those raised segments, especially there towards the left-hand side of the banner, as it's able to start contouring things. Might be kind of hard as it's going around, but you can see that we've started to form the lettering in the middle a lot smoother. We're starting to get some definition on the leaves. As it goes around, you can see where it's removing more and more material. Still a little on the coarse side just because of the size of bit that I selected. We're starting to see a little bit of the formation in the lettering, but still not the level of detail that we would want to see. So we're almost to the completion point there as we go through the center of the device or the item. You can see as it's going around here, it's still carving just a little bit more into the recessed portion of this plaque. Now that it has a little bit finer detail bit, it's removing just a little bit more material to get us where we want to have our end result at. It's going to start giving us the taper on the edges of our plaque going up the edge instead of the steps that we saw with the end mill initially. Now this particular pass took about an hour and 10 minutes, hour and 15 minutes. So that gave us what we ended up with there. So you can see, as I mentioned, we start seeing some more definition in the lettering. We start seeing the tapering on the edges of our device, or our project. At the end of that, here's the detail that we had with that. Now, some of the what may look like strange artifacting in that is due to the grain of the wood. That's these dark lines going through the word Thanksgiving, as well as through the word happy. Those aren't squiggly parts of the carve, it's actually the grain of the wood. But we did start to get more detail in there. We've got some good idea of how the lettering is going to be laid out. So then we just keep moving down our list. We load our next toolpath in. So we bring our other finish in. It doesn't really look to be a whole lot different as far as easel is concerned. We're just seeing a big blue spot because it's going to take this now smaller bit and run over the entire process. So let me get this one set up real quick. Now, because I was using a smaller bit, this video did, or this stage did take a lot longer. This particular phase of the project, using just a 3mm ball mill bit, or ball nose bit. The ball nose allows you to get into a tighter detail section. So you can get somewhat finer. So let's go ahead. It's doing the same thing. We're starting in the center and work our way out and around. Let me slow this down just a tad so we can maybe watch as it proceeds. As it's uncovering that center section, you can see that we're starting to see more detail in the lettering. That happy is looking a little bit happier, to get kind of Bob Ross sounding. We're starting to see more detail in the banner, more detail in the leaves. We're not seeing so much on the depth of our project. Most of that depth was identified and defined as we went through the first finishing pass. So it doesn't have to cut quite as deep for this one. We're starting to see, as it gets into the other lettering, we're defining more in the lettering as well. But since we did run such a smaller bit, it does drastically impact your carve time.
Paul Krause wants you to go into a little bit more detail as to which bits to use and why.
Alright, we had a request about which bits to use. The selection of bits really comes down to what your project consists of. Very similar to when you're working on a project in easel, you want to use the largest bit that will fit with your design. So if you were working in just easel, we would always see that preview on the right hand side of the screen that says this is what it's going to look like, and as you change bits you will see that change as well. Using the largest bit that you can to fit in your design will allow you to run at higher speeds. The finer the bit is, the slower you have to go to prevent breaking a bit. For something like this, with that script style lettering, as I mentioned previously, I probably could have gone to the V-shaped bit, the engraving bit, to get into that fine detail. That would have allowed us to get down deeper into the lettering a little bit. The sacrifice you make with that is time. It's going to take a lot more time to do that. because of the surface area that you're removing. Because if we're using, to do the bulk of that material removal, I used a 6 millimeter diameter bit. So every time it moves across that wood, it's removing a path of wood 6 millimeters wide, or a quarter of an inch wide. By comparison, that engraving bit has a cutting tip of 0.1 millimeters wide. So it's removing 0.1, the 6 millimeter is removing 60 times that. So obviously that 0.1 millimeter bit would take 60 times longer to remove the same amount of material, or 60 passes to clear a path that same width. That's why we always say go with that larger bit. There is going to be some experimentation on some of your projects. We did one project here that was a flag design that was a lot of lettering. It's actually the preamble to the Constitution, where all we did is we stained a board and then carved the lettering into it, allowing the carving to bring the bare wood out in contrast. We did that with a 1/4 inch V-groove bit, because for the script style lettering, carving into the wood instead of a relief like what we have here, that gave us a better outcome. So that's where you get into your bit selection, is how your project is laid out and what sort of effect you want to see from it. Hopefully that helps answer your question.
He says, so you have to have some kind of knowledge what each bit will do.
Yes, the question was, you have to have some knowledge about what each bit will do, and that is correct. Your end mill bits are pretty much for removing large volumes of material. We use the bigger ones for that roughing bit pass. Yes, we do have the very small corn mill bits. Some people will use those to get into that fine detail. The advantage to using those very, very fine corn milling bits instead of an engraving bit is the fact that they have a straight cut bit. The engraving bit, if you're going too deep, will give you a tapered kerf just because of the design of the bit. So if you want to do very, very fine detail and you don't want it to be a sloped side, you want very precise upright edges on your relief, that's where you would use one of these smaller end mills. The flat nose bits will work very similar to the corn mill bits, but with the fluting, they will help draw the material and sawdust up out of the hole. Those would be very good if you were trying to do small holes, like I've seen projects where people have done cribbage boards. You'd want to use a flat nose bit for that, because it's going to drop down in and drill that hole and pull the material back up out of it so it doesn't foul up the bit. Your ball nose bits, like what I used for these two finishing passes here in both the 6 millimeter and 3 millimeter, give you more contour. They're really cutting primarily at the very tip of the ball, but as they pass along contours, they will give you a smoother edge as they transition in a 3D element. And then the engraving bit is for that very, very fine detail. So that got us to our final finishing pass. Let me bring a picture up of that real quick.
Can you use the same bit sets for the 3018, or is the shaft size needed smaller or bigger with the 6060 router?
All right, question on bit sizes and bit selection for the two devices. The 3018 uses 1/8 or 3 millimeter shank bits, which is all of our essential bits. You can also upgrade to the V-groove bits and the additional collets, which will allow you to run 1/4 inch shank bits in the 3018. The supplied spindle with the 6060 uses that exact same ER11 collet. So you can use the 1/8 inch bits, or you can get the 1/4 inch collet and run the larger bits with it. The bits are totally compatible between the two machines. You'll notice in the videos that I'm using the Makita router option. The Makita router does come equipped with only a 1/4 inch collet. There are 1/8 inch collets available for it. At this time, we don't have them available, but if you're interested in getting one, send us an email and we can get you the correct source for one. There's a couple different options out there. We can recommend for you the ones that we feel are the safest and work the best, because there are two different types. One is a complete collet replacement, the other is a sleeve. The sleeve ones have proven to not necessarily be the most robust, and if they break, you're slinging a bit at 10,000 RPM across your workshop. But in a nutshell, yes, the bits are compatible across the two machines. So here was our finished project, and you can see that we've got a lot more layout, a lot more definition in our lettering now. Again, I probably could have gone to that finer bit, but we're not sure yet how we're going to be finishing this one. If we just want to stain it and then maybe take a paint on a hard roller or ink on a hard roller and run across the top of the lettering just to highlight that and accent that against the wood grain and against the stain of the rest of the material. It's a little hard to see. I didn't realize until after the carve that rippling effect across the word Thanksgiving looks really strange, so it does make it look weird. The final cut that we want to do is to actually get our cutout done so that we can cut this out of our piece of wood. So I'm going to import my final G code, which is my profile cut. Now notice when it comes into easel, it's just a ring of Toolpath. But you can see those little notches in it. That's where it's going to leave those tabs. So let me bring that up.
I want you to show me the 1/4" bits of the teaser.
I don't have them up here. We do have some new 1/4" bits that are going to be available. I've mentioned a couple of them here. Unfortunately, I don't have them on hand right at the moment. They're going to be available on the website very soon. We have 1/4" shank bits. We have a 6mm end mill, which is, as I mentioned, what I used for my roughing pass. We're going to have the 6mm ball end or ball nose. We're going to have a engraving bit that is a 1/4" shank, so not quite as fragile as the original bits. We're going to have a spiral angled groove bit, which is kind of a weird one. We'll get pictures of that up for you, and I have not done enough research on that one to give you the exact application of where that's going to be best used, but we will get that once we get the product page up. And then we also have what they call a bottoming bit. For those of you that are doing like bowls or large cutouts where you just have a large open space in your material or in your project, this is a 1/4" shank bit that is capable of cutting a path 7/8 of an inch wide, or approximately 21mm wide in a single pass. So if you need to remove a lot of material, that's the bit that's going to do it for you. Like I said, I did not grab them to put them on video, and Alban asked for them at the last minute when I wasn't ready for it, so he doesn't get the pictures right now. So, our cutout pass, this was our final pass. We're just going to go around the edge now to get us a cutout. My vacuum wasn't quite wanting to keep up as it was throwing chips in the middle as it dug down deeper and deeper into the wood. But all we're doing is cutting down into the material around that outer vector line that we drew. And you can see, if we back up just a few seconds, if you catch quickly on that video, the Z-axis was moving up and down just slightly. That's giving us those tabs. So when we do that, this was our final cutout. You can see where it cut around the edge. And I was probably going a little aggressive, so it's not as clean a cut. I might have gotten a cleaner cut using an end mill instead of the ball nose bit. This shows a little more of the detail in here around the edge of the leaves. Again, this is pine, so it's not going to give us a very, very smooth edge necessarily, but we can see the detail in there, where we came up around the edge, where we came around the lettering. So that gives us some outline there. And I have one other picture. This was simply to point out, you can see after this cut out, this is where it left those little tabs. Once it was done cutting it out, I picked up this piece of wood, just wrapped it with my fingers, and it dropped the plaque right out of the piece of wood. That was enough to break those tabs loose. They're not very wide, they're not very thick. They're enough to hold the project in position while we're working on it, but not so much so that you have to get a saw out to cut through them.
Does Vcarve Desktop offer the high def option for seeing your final project?
Okay, the question came up, does Vcarve offer a high def option? That's a good question that I don't necessarily know the answer to, because honestly I am still learning Vcarve myself. It does give you, I don't know if their more advanced programs give you a higher definition look. Vcarve has been proven to be sufficient for most of the projects that we're running. They do have a system option called Aspire. That's the one that's up there at that $2,000 license fee. Gives you a lot more flexibility. There are some limitations within the Vectric software. You'll want to take a look at those, because Vectric Vcarve Desktop gives you a maximum workspace, I believe, of 24 by 24 inches. So if you need to cut something larger than that, you have to go to the Vcarve Pro, or start learning the tiling process of that, which can be a learning curve in and of itself, and we may get into that in a later option or later lesson. The whole purpose for this evening was really just highlight the capabilities of the SilverBack and show that the 3D carving can be done. Obviously we can't do it within easel. I can tell you that because we are easel partners, we've been speaking with their engineers. 3D carving is something that they want to bring out in the future. However, they are limited by the functionality that's available from a cloud-based platform, as well as the fact that that would probably be a pro option only, just because of the extra work involved in it. So as they make changes to easel, we may see improvements like that. Those of you that have bought machines recently have also probably noticed that now when you're setting up your machine in easel, you can select the YoraHome machines, either the 3018 or the 6060. We're still fighting with that COM port issue on the SilverBack. However, we've worked with Easel's engineers. They've got some information. They're trying to work on getting that resolved so it'll automatically connect as well. So hopefully that makes life easier for everyone. But that pretty much wraps us up for the evening. If you have any other questions, feel free to post them on the video feed or send us an email at support@yorahome.com, or even just post in the Facebook users group for those that are members. And we will try to answer your questions as quickly as we can. With that, I'm going to go ahead and wrap up for the evening. And I hope everyone enjoys their coming weekend and the coming holiday. Everyone have a happy Thanksgiving. And you all have a good evening.